Hello, Spark fans, and welcome to the first Advancing Spark of 2022. It's a new year. There's lots of new stuff. There's lots of new things to talk about. And so today, I'm going to talk about something that's been around for an absolute age, just to ease us back into the swing of things. Now, you might be getting back after taking some time off. You're full of mince pies, and you're like, right, what's been going on? What's going on in the world? And you want to know how your Spark clusters have been handling your absence. The exciting topic of monitoring your Spark systems is something I want to touch on today, and it's something we've had quite a few requests of going, can you explain what Ganglia is? How do we get to it? How do you use it? There's lots of little things in there, but where do you even start? Now, I've mentioned it before when we did a quick dive into the Spark UI, and I want to kind of just reinforce that Ganglia is an incredibly useful tool for understanding the load on a Spark cluster, for understanding, we're having performance problems. What is it? Oh, that particular executor in my cluster is out of memory. Cool, we must have some skew somewhere. Or we ran out of disk. Or there's too much network. Or my driver is suffering for some reason. Now, Ganglia is that nice telemetry overview thing that lets you diagnose that kind of problem. But people don't tend to look at it. It's baked into Databricks. You can just open up Databricks and go, show me Ganglia, and it will tell you how your cluster is performing and what the current load is in. Now, it'll only work while your cluster is still turned on. So if you're doing like a little overnight ETL load, you turn your cluster on, do a lot of stuff, turn it off again, you can get your snapshot metrics. It won't preserve the entirety of all the metrics for you unless you take it out and you put it into another tool. And we'll look at a few of those options in some future videos. But today, the basics, I'll show you what Ganglia is, I'll show you how I go about diagnosing some of the basic things you can see in it, I'll show you around a couple of different views and some of the bits that just doesn't work in the Databricks implementation. Bear in mind, this is not the full set that you get inside of Databricks. And yeah, it'll equip you to get back to grips with things, to get back and figure out how things have gone over the holidays while you weren't there. Is your cluster still okay? And that'll kind of warm you back in, get you back into the swing of things. That's the plan for today. If you're new around here, that preamble will make no sense whatsoever. Don't forget to like and subscribe, say hello down in the comments, and check out the previous video on the Spark UI that I'll drop a link to below. Until then, let's go and have a look. Okay, so I have opened up Databricks for the first time in weeks. And I want to figure out what's going on. I know that there's some queries that have been running. I've just ran a query that I know has got a load of skew in it, just so we can have a look at some stuff. We want to try and diagnose what's going on. Why have we got a problem? Now, we could look at specific jobs. I could drill down into a job and go, right, okay, what's going on inside there? What are the stages? Oh, that stage was run along. What are the tasks? And I can look at a specific thing, but maybe there's thousands of things going on and you don't know what it is. You want that higher level thing so you can figure out which jobs and tasks and stages to look at. The Ganglia is great at that overall cluster health perspective. We're going to start off, we're going to dive onto our cluster. You can see I've got a cluster running here. It's got my latest cluster. I've got all my different options along here, and the one we're interested in is metrics. You can see a little link that hopped up there. Metrics is where we've got the link to the Ganglia UI. So Ganglia is an open source monitoring thing that comes with, it's built on top of Spark. It's for doing things like operational telemetry on top of clusters, such as a Spark cluster. And it is baked into Databricks, so we can go and have a look at that. We'll have a look at some of those historical snapshots in a set. So if I just click on that, that's going to bump open a new page, and you get this big old diagram of this is what's going on my current cluster. So this is based on the cluster I've currently got turned on. So because I dug into my latest cluster, latest is the name of my cluster. So I dug into this one, went to metrics and opened it from there. It is specifically looking at that particular cluster. And there's loads of different options and buttons, and I found it a little bit overwhelming when I first came in here because there's so many different things you can see. Now, real easy, just slap bang, center of the screen, good dashboarding is, well, kind of good dashboarding, but there's so much junk in here, it's hard to read. But still, the most prominent thing is these 4 quick tiles that give you an overview of your current cluster. There's not breaking down an individual executors, your driver, or anything like that. They're saying for the whole cluster, here's some basic stats. We get these 4 things. We get one generic load. How much stuff is it doing? How many processes are running? How many, kind of like an equivalent of how many jobs, tasks, essentially how much work, an abstract notion of work is their whole cluster doing. So we get an idea of what's actually executing, what's actually going on in that cluster as a whole. And then breaking that idea of how busy is my cluster down, we've got overall memory usage. So how much memory is being used for caching data, for processing data, for storing stuff, for generally how much of the RAM across those various different nodes within my cluster is being used. And you can see there's something kicked off that actually started using a chunky amount of the available memory. So there's something we can go and have a bit of a look at. CPU, similar idea. We can see some spikes, we can see some ideas, we can just see how busy is my cluster. And again, networking the same. So away from any particular troubleshooting, away from any particular problems, I might just open this and go, right, how's my cluster going? Oh, whoa, CPU is going crazy. And I'd know that something's going on. Are people actually using my cluster? Take a look. Yeah, CPU is actually pretty well utilized. The cluster's being used. Great. That general idea of how busy is your Spark cluster, you can get a good idea from here. Now, because this contains everything, it's not always going to be great. Now, if you imagine I've got a real basic little cluster. Right at the bottom, you can see I've got 3 nodes. And that means I've got 1 driver and 2 executors. So if I've got like loads of free spare capacity on my CPU, well, actually, that might be that the driver's not doing much, but the workers are both fully loaded, and that's a pretty good pattern for a cluster. So maybe that's not a worry that I've got 1/3 of my available CPUs fairly free, because the driver said, right, there you go, workers, there's some work to do, and it's just waiting for the work to come back. So don't take it as gospel when you're looking at the cluster level, exactly what that means for your Spark cluster, but it's a really good, just quick sense check. A little bit heartbeat pulse kind of thing of going, how busy is my overall cluster? Memory, CPU, network gives you an idea. General load spikes gives you an idea. So looking at that, I can say, well, okay, there's stuff going on in my cluster. There are some pretty heavy CPU spikes. Because they're kind of quite short spikes, I can kind of assume that this is only 1 or 2 queries kicking off. If you're using kind of like a serving cluster, lots of different people sharing it for ad hoc analytics, you see a much more kind of spiky, ongoing usage as different people came in and ran their different things. If you looked at this and you saw like a big maxed out pile of CPU, go, ooh, okay, maybe we're using too much of my cluster. Maybe we need to think about adding some workers. But maybe you shouldn't. Is there a problem? Is it a skew? Is it just one worker that was maxed? And there's all those kind of questions that we can start asking of it. So great starting point. That's just kind of a little bit in the middle of how busy is my cluster. But we'll have deeper questions. We'll have deeper things to go and dig into behind it. So a few quick notes before we actually dig into some of those details. One, all these tabs along the top are great in your bog standard vanilla Ganglia. Not so useful in your Databricks embedded version. Lots of them, if you dig into it, it will kind of give you a, no, I'm not particularly happy. My cluster refused to connect. You don't really get the stuff you need from it. So generally, as sad as it is, I'd say kind of ignore all the other tabs along the top. If you stick with your main tab, which is kind of giving you that general cluster overview, probably going to be a better place for you to be playing around and digging into it. So we'll stick with this main overview metrics thing for now and kind of ignore the other sections because we're talking about Databricks specifically. But there's stuff that we can do. So I've got a load of time-based things here. So I can actually say I'm currently looking at the last hour's load. If I was looking at a cluster that's been turned on for quite some time, again, you'll lose these metrics whenever you restart your cluster. But if you're looking at it and they've been turned on for a while, you can go and have a play with the different time zones that all and just affect all the charts that we've got. I can put a date period and date range. I can change how kind of what time zone it's using, whether it's a server, whether it's actually using the browser, kind of where I am versus where my Databricks region is. There's a few bits and pieces you can do. Generally, because we tend to be talking about clusters that are turned on for shorter periods, a few days, a few weeks, then we wouldn't tend to look at the big long running ones unless you're doing something slightly crazy. So we've got that. We can also dive over to this physical view, and that gives you kind of like a little current heartbeat, a little snapshot of what's going on these things. So we can have a look at generally what my 3 nodes. So again, I've got 2 executors, I've got a driver. I can't really see from this which is my driver. And I can dig into it. I can go and say, well, that's what's going on in there and get some general info about this stuff. Gives me a rough idea of what the node is, but not too useful. What's better is the more detailed reports we've got underneath that original summary report. Just be aware, there's a few things we can click into and we can explore and we can go and see what's happening there. But if I wanted to understand this and go, right, okay, so I definitely had a CPU spike, and then there's like an ongoing bit of CPU usage that, you know, why is there that? Was it like a long running job? Was it just something that took a little while? Was there the driver had a problem, we can go and explore and say, what is that problem? And we can see, why was it using so much memory? What's going on there? So let's go and dig in and understand it. And to do that, we've got these reports slightly lower. Now, what we've currently got, you can see this load one, kind of like what is the current view of things. We've got various things like the load report. And this is essentially just a giant list of what do I want those graphs to show. So it's going to show me one chart for each of the nodes in my cluster. If I take a quick step back and we dive into the Spark UI, if I dive over to this executors tab, I can put a little bit context behind those 3 IP addresses. So you can see I've got 3 executors, 0, driver, and 1. So my driver, you can see, is 10, blah, 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 actually 0.6. So 0.6 is my driver. The other 2 are workers. So in my Spark cluster, I've got 1 brain at the top, 2 grunts doing the work. So I know that the one that ends in 0.6 is my driver, and 0.4 and 0.5 are both workers. If I go back onto my Ganglia report, I can see 0.6 over on the right-hand side. That's my driver. So that's showing a different work profile to my 2 worker nodes, which makes entire sense. It's a different kind of part of my overall cluster architecture. So I had a spike at the start, was figuring what to do, and then it just pushes work for the workers to do. So you can see it goes, oh, lots of work, and then just chills while the workers actually do their work. That kind of makes sense. So I've got 2, what's going on in my actual workers? My driver's nice and quiet. So let's try and understand some of what's going on in here. So we've got the load in the last hour, which the load one is kind of giving us an idea of what's going on there. But let's dig in and say, okay, I want to understand this memory. So what is going on with my cluster memory? And I can dig in this. I've got my giant list of all these different reports. And generally, the one that's underscore report is that quite useful overview style thing. So I can look at a specific aspect. How much free memory, how much cached memory, how much shared total memory. I can do all that. Mem report gives you that kind of overlay of what you need to know. Essentially, it's that same cluster memory, but broken down by executor. And this shows us something interesting, right? So I can see, well, my driver, nothing particularly was happening in there. Let's just have a quick play with this and change the size of my graph so I can see them a little bit better. There we go. You can see on my driver, fairly steady. It's not using a lot of memory. It's fine. And then one executor, there's a sudden burst of caching some stuff, and then a little bit of ongoing of actually sort of using some stuff. But over here, you can see I hit my memory limit. So I've got that red line is my total memory, and this ran out of memory. And that's a warning sign. So that's saying, well, actually, so something happened when it tried to put a load of data, and rather than spreading it evenly across my executors, something happened that just completely filled up the memory on one of my executors. And that means things like it's going to start spilling out to disk, it's start doing really expensive write operations, it's going to be doing some fairly gnarly stuff. So actually, whilst my cluster memory looks fairly happy, that's fine. When I look at it at the worker level, I can see, ooh, something bad went on. So let's see, did it do a spill? Do I have some problems here? Well, I can dig into disk. I've got my disk report in here. Let's go up and down, disk total. Disk report, there we go. So what's going on in terms of disk? And you can see I got a real funny one on one of those big things. So my driver, perfectly happy, not much going on. One of the workers, a little spike when I had to write some stuff out to this, but not too much. One of them, oh god, it had problems. It suddenly went into negative in terms of disk. Suddenly it got very, very confused about how much disk it had. Most likely because it started spilling out a load of stuff to disk because there was a load of skew. If one of your executors runs out of memory, has a load of spilling, the other one doesn't, that probably means the amount of work they're doing is very uneven, meaning I had a task which was really, really chunky. I probably had a skewed query. Now, this is the kind of thing that adaptive query execution kind of fixes. So this kind of problem should come up less and less often now that it's turned on by default with the latest runtime. But it's good to be able to go and see it. And it's interesting because actually when we dug into this physical view, one of the things we've got is that most full disk is showing 0.5. Whereas actually one of the things the part of my cluster that's having the biggest problem was 0.4. And that's kind of interesting. I was really confused when I first saw this. I was like, okay. But then it makes a lot of sense when you drill into it. Because actually what it probably means is it's changed the amount of the size of that disk. So that's got 299 gig a disk that's got. And this one has 163. What that means is in my cluster, it started writing out to disk in one of the nodes. It then went, oh, okay, I've run out of space. I'm going to have to allocate a bigger disk to this VM, which takes time and it takes settings and it waits for it to do it. So we can start to see some of these patterns. Some of the key indicators might be hiding some stuff. So let's go and have a look at what we should see in the event log. Here we go. So one of my instances expanded this disk from 152 gig to 280 gig because it started running out of space. Didn't run out of space that much, but it started seeing it was using up the disk. So that kind of proves what we're looking at. We can start to get this idea and stitch what's going on in terms of Ganglia by looking at these different metric reports. By having an idea of going, well, I've got my disk report, my network report, my CPU report, my memory report. I can actually say, take my cluster level stuff, which gives me a nice overview, but might hide away some details. And if I think there's a problem, I can just quickly flick between those reports, have a look at how that looks across my various workers, and then go, yeah, there was a problem. So now I know there's some kind of disk spillage. There's some kind of writing out to disk problem that it was happening. Other one, so CPU, we can just kind of have a quick look at. And again, we see a big difference between the two. Again, driver has its own CPU profile. Our two workers you'd expect to be very similar, but actually this one had 2 spikes and then it finished all his tasks and it just sat there going, this is cool. And then one of them went, right, okay, gonna do a load of work, I'll do a load of tasks, and then, I'm gonna sit there working for a load of extra time. And, I don't know what time period, a good 10 minutes of extra grunt happening on one executor, not the others. That means we're not doing things fully in parallel. That means we have skew. Again, it's very unlikely you'll have a cluster sitting there doing nothing else and you can run a single query and identify their stuff. I'm trying to show you in a nice, clean, sanitized environment how you spot this kind of stuff. But just generally looking across your different executors for very glaringly different CPU usage, memory usage, looking for any disk spillage, you can start to go, okay, there's a problem there. We know there's something happening. Now, we can actually sort of do some of this stuff by drilling down even further. We can go and have a look at specific jobs that ran and then get the profile for that job. I mean, obviously, you've got the normal Spark UI stuff, so we could dig into here and say, well, actually, let's have a look at the jobs. Obviously, I've got my skew ones that I was using to force skew, and you can dig in, and again, there'll be no surprise, I think, when we go into here. If we drill down into the one that took the most time, so shuffle read of 8 gigs, probably where we had the skew. And then we'll see kind of the task allocations. There we go. There's one dirty great task. Most things we're doing around 12 meg, 12 meg. This one doing a hell of a lot more than anything else because there was skew, because it's an artificial thing. I think I've even used that example in a previous video to show skew when AQE first came out. So actually diagnosing it, you go through the normal stuff. You're looking in the Spark UI, looking at jobs, you're looking at your stages and tasks and trying to figure out, right, I had a problem. We're trying to figure out what is going on my overall cluster, and are there problems? Are there any things I should be looking for? Do I need to worry? Or actually, hey, everything ran fine. I've got no red marks all over my dashboarding reports. I'll just crack on, there's no problems. This is a good way of just getting that overall sense check, the overall health check. Now, I don't have an example I can show you, but another thing I had of this is when the cluster looked really quiet and memory usage was fairly small, CPU usage was like tiny. And so kind of generally, from the client's point of view, looking at the Spark cluster is like, there's no problems here. Why is everything going so slow? And what it actually was a driver issue. So there was lots and lots of Spark streaming tasks all running together, each of them not really doing much work, but having 15, 20 different streaming jobs on a fairly small driver, and the driver was just constantly restarting micro batches, a huge CPU usage on the driver node. So when you looked at this kind of view, you'd see the driver just had a heavy CPU usage, but the actual workers were barely doing anything. They were processing a couple of records, write it down, a couple of records, write it down. And to really understand how that was going, you had to look at this node by node view to go, oh, the driver's really struggling. They don't need to add more workers. It's not a just make your Spark cluster bigger, because it's not going to help because your bottleneck sits there. So understanding whether something is a problem with skew, aka one of your worker nodes has got a drastically higher usage than other things, or working out if you need more worker nodes, basically because all of your workers nodes are actually experiencing fairly high usage, fairly good utilization. You're like, maybe this actually would help if we just added some more workers to it. Or working out if it's a real driver-based problem because the driver is actually suffering from very high utilization and your workers aren't really being touched. You can get that information from Ganglia. You can get that by going into your Ganglia report, looking at the high level stuff, which would hide things away. If the driver was a problem and all your workers are completely free, this is looking peachy. You'd have no problems up here. But then looking down at this node level, you'd see one of them was just massive spikes and you'd have a load of problems there. So Ganglia, incredibly useful for diagnosing this kind of stuff and trying to understand, is it a problem with one worker, problem with the whole cluster, problem with the driver? You can start to diagnose that by dancing around your different reports in here, having a look at your cluster overview and having a look at your node-based ones. So please use Ganglia to understand what's going on. As I said, we're going to have a look at some other stuff in future videos to do with how can we scrape this and get a longer term one? If I'm turning my cluster on and then off and then on and then off and then on and off, how can I actually understand what that looks like over time? If I've got 3 different Databricks workspaces and I want to understand the overall usage, how do I do that? And there's various different ways we can scrape some of this info and then look at similar ways of displaying it. So it's not the be all and end all Ganglia. It's just a really nice baked in start that is inside of Databricks already, but no one ever goes onto that metrics tab. No one ever clicks on that Ganglia UI button because honestly, it looks a little bit scary when you first open up because it looks quite old school and there's lots of diagrams and dials and buttons that don't work. But there is so much value to actually start tackling that stuff and start digging into it. So definitely do that. This thing, historical metrics. So there's all these different pictures, and this is essentially like someone just taking a screenshot of the Ganglia report itself. So we're going to have a look at one of these metrics, and that opens up essentially just an image. This is just a picture of the same file. We can zoom in, there's no buttons, we can't actually use it. It looks like you can, but it's really confusing. It is just like someone's taken a snapshot of that metrics report with the overall cluster health and then your various different things. Now, whenever we've got the cluster turned on, you can get this. So if you want to have a quick look and go, everything went really slow last night, but we've restarted the cluster since, so I can't open the Ganglia UI and actually just interrogate it and cut and slice. You can at least go in and say, right, what's the metrics report from when that was turned on? What was happening in the cluster? And you can get the nearest snapshot of that information. So the snapshots, they're useful. They're obviously very limited. I can't cut and slice this. I can't drill into it. I can't dig into any more information. I mean, a lot of the reports you've got in here, actually, we can drill down even further into these. If I just click on that, I can get kind of the time-based breakdown of all this different stuff. I can get the different metrics side to side. We can see lots and lots of info and drill further and further and further inside the Ganglia reports and then take it and slice it from different ways. Tons and tons of stuff you can do inside Ganglia. Can't do that in snapshots because it's literally just a picture showing you what's going on currently. That has value, right? If you weren't trapping the metrics, you can at least get back to it and go and query it and say, what was happening? Okay, one of the workers had massive amounts of load compared to something else. All right, okay, we can start digging into it and try and understand what happened there. It's giving you that starting point of what went wrong? How do I start? Where can I go and fix it? So please, if you're getting back into the swing of things, you're trying to understand how things are going, you want to kind of get ahead of stuff, just go onto your clusters, open up the metrics tab, open up the Ganglia UI, and just start familiarizing yourself with the different reports. Disk report, CPU report, network report, memory report, all good places to start with. And then if there are particular metrics that you actually start associating with problems, by all means use the specific reports and dig into it. I give you the how to get started. Where do you first look when trying to figure out what's going on a Spark cluster? That'll be a really good start and actually get you practiced at trying to diagnose this stuff. Okay, so that is all I want to do today. Just a real simple little, let's have a look at what's there, have a look at how I use it to diagnose problems, what some problems look like, go nuts, have a look at Ganglia and see where you get to from there. Now, there's a whole load of other stuff coming up. I've got lots and lots of videos in the pipeline, so stay tuned. We'll be back onto the regular cadence of setting out lots of videos from now on, back in the office, back to work. Lots of videos to do. Until then, don't forget to like and subscribe. Let us know down in the comments, do you use Ganglia? What's your favorite report of Ganglia? That's a nerdy topic, but I love it. So, do you use any other tools? Are you using things like Databricks Labs Overwatch? Are you pulling it out, putting it into Datadog? Are you doing other things to monitor your Spark clusters? Let us know. If you've got any much better things, if you've got any tips and tricks for Ganglia, then let us know down in the comments and we'll share it out. Until then, thanks for watching and I'll see you next time. Cheers.